talking about two-dimensional structure as well as three-dimensional structures. In the two-dimensional structures, we have observed the equations of equilibrium as these three equations of equilibriums are there, whereas for the space structures, there are six equations of equilibrium they are available. Right. So we observed for the plane structure, two-dimensional structures, the equations of equilibrium are sigma fx is equal to 0, sigma fy is equal to 0, sigma m about any point is equal to 0. Whereas for a space structure, we have seen that they are along with the uh, x and y, here z-axis is also available. Hence, for the z-axis, sigma mx is equal to 0, sigma my is equal to sigma m about z is equal to 0, along with the summation of the forces along x, y, and z-axis is equal to 0. Now, in the another category, we observed that structure can be classified into two categories, stable structure as well as unstable structure. In the stable structure, we have seen that um, here I asked you people to solve these three problems. What you have done, first of all, for the first problem, draw the free body diagram. So when you draw the free body diagram, just here itself I am drawing. Here this is a hinged support. For a hinged support, here this is R A. I am writing it as Y. You can also write it as VA, that is vertical force at A. That is also we can write down. Otherwise, I can write down it as along Y axis RAY. And this is along X axis RAX. There is force along X, force along. Whereas here, what is the force here? It is a roller support. So for a roller support, only one vertical reaction is there. This is RB. Why that is, but however I am writing it as RB. There is reaction at B. Reaction at A along Y direction, reaction at A along X direction. Now, your force, this can be resolved along x-axis, along y-axis. So, this is 50 sine 60. This is 50 cos 60. So 50 cos 60, that is this angle is 60 degrees. So 50 cos 60. So what is the value of 50 cos 60? 25. So this will be 25 root 3. So now, how many unknowns are there? There are three unknowns are there. How many equations of equilibrium do we know? There are three equations of equilibrium. That is, sigma fx is equal to 0, sigma fy is equal to 0, sigma m about any point is equal to 0. Just listen. Here, summation of the forces along x-axis, along y-axis, about z-axis. Z-axis will be perpendicular to the plane. Now, RAY plus, so when you write down sigma fx is equal to 0 plus RAX, this 50 cos 60, this is also acting along x-axis, so plus 25 equal to 0. So RAX is minus 25. Please note down along with me. All these points you should note down. So sigma fx RAX plus 25 is equal to 0. RAX is minus 25 kilonewtons. Whereas coming to sigma fy is equal to 0. RAY plus RB minus 25 root 3 is equal to 0. Solving the problem regarding first one, we started replacing the problem like the beam with unknown reactions. These unknown reactions at hinge are RAY along y direction, RAX along x-axis, and here our axis will be this is x. So this is RB. So RAX plus 25 is equal to 0 along y-axis, summation of the forces along x-axis, summation of the forces along y-axis, RAY plus RB is equal to 0. Sorry, is equal to 25, minus 25 root 3 is equal to 0. Now third equation is, this is second one, third equation I am writing here. Sigma m about any point is equal to 0. Okay. So here clockwise will be considered as positive, anti-clockwise will be considered as negative. So minus RB 6 plus, you have replaced your 50 kilonewtons vertically along horizontally. So 50 sine that 60, that is 25 root 3 into 3 is equal to 0. So you can tell me the value of RB. So what is the value of RB? What is the value of RB? 21.65 kilonewtons. That is the value of RB. So I know from this equation, I can get the value of RAY. It is nothing but 25 root 3 minus 21.65. RAY, that is RB is 21.65, RAY is 21.65 kilonewtons. So that is what I asked you people to calculate for the first problem. Now coming to the second one, right? Coming to the second one, just take the second problem and draw the free body diagram for second one. This is a P and this is R A Y. This is R A X. This is R B Y. R B X. Now here a slope of force is there which is 50 kilonewtons acting with an angle of 60 degrees. 3 meters, 3 meters. Now tell me how many unknown forces are there for the given. First of all, with the given loading, how many reactions are there? 1, 2, 3, 4. A total of 4 unknown forces are there. As per for the plane structures, there is x and y axis structures. How many equations of equilibrium are available? We know that there are only 3 equations of equilibrium that are available. So when only 3 equations of equilibrium are available, how can you solve 4 unknowns? The structure is stable. This is a hinged support. At hinged support, there are 2 unknown forces are available. So without calculating these unknown forces, the structure becomes indeterminate. So yes, the structure is stable as per our definition. Here the unknown reactions, they are greater than or equal to our number of equilibrium equations. Structure is stable, but the structure has become indeterminate. So with the help of equations of equilibrium, you can't solve this problem. But 3 equations of equilibrium, they are not sufficient to solve this one. Why? Because only 3 are available. 3 equations of available. So the degree of indeterminacy is nothing but R minus n. R is 4. So for this problem, 4 minus 3, so it is 1. So the structure is indeterminate by 1. If I get any one of the value, RAX or RAY, RBY or RBX, then I can solve this problem. So this is indeterminate with the degree 1. Whereas coming to the third one, So draw the free body diagram for this first of all. So when you start drawing the free body diagram for this one, if fixed support here it is there, so a fixed support will be having three unknown reactions. Here three unknown reactions are there. It is restrained to move along x-axis, so unknown force along x-axis. It is restrained to move along y-axis, so unknown force along y direction, and it is restrained to rotate. So the rotation here theta is equal to 0 at the fixed end. So the rotation here it is also 0. Now you are observing that these degrees of freedom for a fixed support are 0 and the unknown reactions are 3. Whereas this is a roller support, here one unknown reaction. Total, how many unknown reactions are there for the given beam? Your unknown reactions are 4, but for the plane structure, the available equations are 3. So R is greater than N. So you can classify this structure as a stable structure, but it is indeterminate. Your normal strength of material principles or engineering mechanics principles are not sufficient to analyze these structures. Hence, you need specialized techniques to analyze these types of problems. Our structural analysis deals to analyze these types of structures. That's why structural analysis, studying the structural analysis is important, where you are analyzing statically indeterminate structures. Am I clear to you? Shall I repeat once again whatever I have said? So here, in the first problem, simply with your strength of materials concept, with the help of equations of equilibrium, you are able to calculate the reactions, whereas the structure has become indeterminate according to the type of the support. Those types of structures are to be analyzed with not only with these equations of equilibrium concept, you require additional equations. Those additional equations will be supplied by a particular technique in structural analysis. Right? So with moving with this, I am entering into structural analysis concept. In the structural analysis, once again, some of the problems we will analyze with the help of equations of equilibrium. Some like we will classify the structure now. Just let me go back to the classification that we started here. So what we have written a structure classified as stable structure as well as unstable structure. So these unstable structures are not analyzed here. We are analyzing stable structure. These stable structures, once again, they will be classified as, let's write down them as determinate structures as well as indeterminate structures. So they will be classified as determinate structures, indeterminate structures. So these determinate structures we are analyzing with the help of so can be analyzed by equations of equilibrium. Can be analyzed by equations of equilibrium. Whereas indeterminate structures they are to be analyzed with the help of structural analysis concepts. Needed to be analyzed structural analysis concept. So these indeterminate structures they will be classified into two categories. One is static indeterminacy. Second one is kinematic indeterminacy. So structures they will be once again classified as static indeterminacy as well as kinematic indeterminacy. Okay. So we understand the classification of structures, and here we are coming across concepts of structure. Shall I repeat any of the concept once again? If you want for the classification, I will once again repeat it. Let me know your response. Shall I move further or shall I wait once again for you?
Once again, sir.
May I know your name or roll number?
Rajshekhar 20,
Yeah.
105.
Once again, why? Because these concepts are very important to understand the structural analysis. In civil engineering, analysis is a slightly it is the most important one and slightly typical one. But if you understand, it is very easy. Just once again, let me quickly come back. Most of the students they recently joined. That's why I am once again repeating. We are combining of elements to form a structure. So here elements of our building are nothing but footings, columns, beams, slabs. You can also say walls are also elements of a structure. Yes, you can also add. I am not dealing with whether it is a structural member or non-structural member. So walls can also be considered as the elements of a structure. Here in this analysis, we are considering the structures as three categories: one-dimensional, two-dimensional, as well as three-dimensional. The one-dimensional, the bars which are being subjected to axial compression as axial tension. That means along the length of the member only the forces are acting. Like this only, either it is tension or it is compression. Whereas coming to two-dimensional structures, here the example analysis is nothing but beams, slabs, trusses. Whereas coming to the three-dimensional, that is you are considering in the analysis in the two-dimensional, the thickness of the member is not assumed. Whereas in the three-dimensional structures, you are considering the thickness also along with length and breadth or length and width. So dams, reservoirs, retaining walls, all these they will be considered for the three-dimensional analysis. They will be considered for three-dimensional analysis. Yes, if you observe the structure in another classification where plane structures as well as space structures. So plane structures we call them as two-dimensional. Space structures we call them three-dimensional. In plane structures, you will consider the equations of consider the equations of as a three. Equal to 0, sigma fy is equal to 0, sigma m about any point is equal to 0. Whereas space structures, here the space structures are sigma m about sigma fz, that is summation of the forces along x, along y, and along z axis is equal to 0. summation of the forces about summation of the moments about x, about y, and about z axis is equal to 0. This is along the length. This is about. Moments are about a point. Forces are along the line. So you should what is the point that you need to understand? For a plane structure, how many equations of equilibrium are available? For a space structure, how many equations of equilibrium are available? 6. So now a structure, when you understand a structure, this can be classified into, once again, stable structure, unstable structure. So this stable structure, it is when it is set as a stable structure, when it is in a simple definition, you can say that upon application of the loading, the structure should not like deform. It is some, for example, see this road, there are two rollers are there. Just you are sitting on a bench where two rollers are placed at the bottom, and I am teaching the class. Then what happens to you people? Like it is something like example is your computer chair or revolving chair, where if you sit and it can with a small movement it will displace. So that is the structure is not stable upon application of the loading. So those type of structures we call them as unstable. These types of structures are not at all analyzed. Whereas we will study only with respect to stable structures. These stable structures, once again, you have to understand, is it a determinate structure or indeterminate? So determinate structure means with the help of equations of equilibrium, you can solve the problem. So first of all, a structure, it is a group of elements that are combined together. So this is having a beam. If I consider this as a beam, this beam is supported with the different types of supports. For example, I have to understand what is the type of support. So in the types of supports, you people know that there are majorly three types of supports. However, further different types of supports are available. Here, the first one is roller support, where here this can be reformed. Like it can be shown like these two shapes. Either it is like this or like this. Here, restrained, this roller support is restrained to move along y direction, is free to move along x and along rotation along z. Rotation along z is accepted. Sorry, rotation about z is accepted. Now, so the degrees of freedom for a roller support is 2. Whereas for a hinged support, here this is allowed to rotate about z axis, but it is restrained to move along x and y axis. That's why degrees of freedom for a hinged support is 1, but the reactions are 2. Whereas coming to the third one, fixed support, for a fixed support, here it is not at all allowed to move either x, y, and z directions. It is restrained to move in all the other directions, and the reactions are 3. So you should understand here the rotation at this point, the fixed support is 0. Wherever the rotation is 0, there the fixed moment exists. In this case, for the hinged support, the rotation is existing. Wherever the rotation is existing, moment becomes 0. Now, we have seen the problems related to the statical indeterminate as well as indeterminate. If the number of unknowns or the number of reaction unknowns are more than the equations of equilibrium, the structure is said to be statically indeterminate. If R is greater than N, it indicates statically indeterminate. If R is equal to N, then this is called as statically determinate. In both the cases, we can say that R is greater than or equal to N. So these structures are stable structures. And R is less than N, then the structure is unstable structure. I will continue, move further. Please first of all keep heading analysis of perfect frames. This is our first topic, first unit, analysis of perfect frames. So first of all, we should understand what is meant by a frame. Yesterday or today, we have discussed regarding a structure, something like a bar, a beam, column, like that we might have designed. Then what is meant by a frame here? And how many different types of frames are available? So majorly, we can classify these frames into two categories. Two categories. So one is plane frame. Sorry. That means here we are understand. Second one is space frames. So this is a structure. In the structures we are observing frames. These frames we are understanding here two-dimensional frames as well as three-dimensional frames. So plane frames as well as space frames. That is one category where here only x and y direction only the analysis is done, whereas you will consider x, y, and z directions. In these plane frames, these are once again classified in two categories. So the first category is pin jointed frames, rigid jointed frames. So one type of analysis is pin jointed frames. Second one is rigid jointed frames. So these pin jointed frames, so once again, they will be classified. So what is meant by pin joint? What is meant by rigid joint? We will study all these things. Types of pin jointed frames. So these types of in the pin jointed frames, first one is imperfect frame. Second one is perfect frame. Third one is redundant frame. Just listen once again. These pin jointed frames, they will be classified into three categories: imperfect, perfect, as well as redundant. What is meant by imperfect here? What is meant by perfect? What is meant by redundant? That we will see here. So in the types of pin jointed frames, when you understand, for example, there is one equation that is available if m is less than j minus m is less than j minus r, then the frame is said to be imperfect frame. Here m is nothing but number of members, j means number of joints. R is nothing but here number of equilibrium equations. So we know that for plane frames, R is equal to E. Why? Because sigma fx is equal to 0, sigma fy is equal to 0, sigma m about any point is equal to 0. That's why they will be considered it as the number of unknowns will be considered as sorry, there is the number of equilibrium equations they will be considered as 3. So in the imperfect frame, so I am talking regarding imperfect frame. So if m is less than 2j minus 3, I can simplify this equation as m less than 2j minus 3. So this is imperfect frame. You can also consider it as imperfect frame is simply in our simple words unstable structure. The structure is not at all stable. Whereas perfect frame m is equal to j minus 3. M is equal to j minus 3. I'm just drawing the diagrams for imperfect frame. Please look the diagrams that whatever I'm drawing for. This is something like you can call it as a truss. The structure is there like this. So when a structure is there like this, just now tell me how many members are available in this structure. 1, 3, 4. There are 4 members are available. How many joints are available? 4 joints are available. So number of members are here 4. Number of joints are also 4. So as per our equation, 2j minus 3 is nothing but 2 into 4 minus 3. That implies 8 minus 3 is 5. That means here the number of members are 4 only. M is less than 2j minus 3. Hence, the given structure is unstable or imperfect. This is unstable structure. The structure is unstable. Whereas for the perfect frames, just to see this one, this is your structure. So now tell me how many joints are there here. The joints are 1, 2, 3, 4. Joint is nothing but 2 members meeting at a point. 2 or more number of members meeting at a point. So the number of joints are 4. Number of members 1,
5, sir.
3, 4, 5. So members are 5. Then write down 2j minus 3 is nothing but 2 into 4 minus 3, which is 5. So m is also 5, which is nothing but m is equal to 2j minus 3. So this will be considered as a stable structure and determinate structure. Stable and determinate structure. Whereas a redundant frame, the redundant frame, just see this. So how many members are there here?
6 members, sir.
Joints are 4 only. So here 2j minus 3 is 5. 2 into 4 minus 3. Here m is greater than 2j minus 3. So structure is stable and it is indeterminate structure. So structure is stable and indeterminate structure. So in our first major unit, we are studying pin jointed perfect frames. So here in the pin jointed analysis, how we are classifying. So we have first of all seen that the types of frames will be two categories. One is plane frame, another one is space frames. The plane frames, we observed that there are two categories are there: pin jointed frames, rigid jointed frames. So in this, once again, pin jointed frames, they will be classified as imperfect, perfect, and redundant frames. So we are studying now the methods that are to be analyzed for pin jointed perfect plane frames. Next point, methods analyze pin jointed perfect pin jointed perfect plane frames. In that we are solving the methods how to analyze these. So that is nothing but, for example, a truss is there like this, which is being subjected to a type of loading, and I would like to analyze what are the forces internally as well as externally. So for example, a plane truss is there like this. These types of trusses we will use for the roof purpose. So, for example, this type of truss is there which is being subjected to loading like this. So, just tell me how many members are there in the structure. I'm just counting the members: 1, 3, 4, 5, 6, 7, 9, 10, 11, 13. So, total members are 30. Joints, how many joints are there? 1, 4, 7. So J is equal to 8. J minus 3 is nothing but 2. 8 minus 3 is 13. 16 minus 3, 13. So M is equal to 2J minus 3. Is the number of members is equal to 2J minus 3. This given frame is perfect pin jointed frame. In joint is nothing but, you can observe, they are jointed, two members or two or more number of members, they are jointed with the help of pin joint. So what happens at a pin joint? How many equations of equilibrium are to be considered at a pin joint? That we will study further. So here the methods to analyze pin jointed perfect frames, perfect plane frames. The available methods are: first method, method of joints; second one is method of sections; third method is tension coefficient method; so analyzing the perfect pin jointed frame, With the help of these three methods and calculating the internal forces, for example, due to the application of the loading, what is the force inside this member? What is the force inside this member, whether it is tension or compression? So is it tension or compression? What is the type of force? And what is the magnitude of the force? So that's why how much quantity of the force, for example, a 10 kilometer vertical load is being coming, like is coming onto the member. Then for this type of loading, how much amount of force that is there? So you are going to calculate magnitude. Magnitude is nothing but quantity, and nature of the force. Nature of the force is nothing but understand here. These types of members, they will not be subjected to any shear. They will not be subjected to any bending moment. All these members, they will be subjected to axial compression or axial tension. They will not be subjected to any bending. So, in jointed perfect plane frames, they will be subjected to axial tension or axial compression. Right? So, with this, I'm just stopping my class. The next class, we will start analyzing pin jointed perfect plane frame with the method of joints.